Hey everybody, this has been in this topology. What we are going to understand is STP, which is a protocol, which is a proprietary protocol, and it's done by Cisco and it's work in Cisco devices. And that's a simple thing that we are going to make the understanding about this all and all around this topology on what is the STP and what are the terms which is work all around it, and that's all the thing we are going to be understand in a one single topology. Okay, so there's a several thing beyond this, but what are the possible thing that we can implement to it? Let's see. Okay, so first thing, as you can see here, it is the priority and address, which is a quite which is, as you can see and as you can recognize, this is a MAC address exactly. And I will tell you about this, what we call this, and how what it's do in real. Okay, so before jumping to this all numeric thing and understanding about this, we have to understand what STP is. So STP that we call the spanning tree protocol, and which is working on the basis of the IEEE standard, which is 802.1d, which prevent the loops which is created by the broadcast storms, and some ways it happens. So what it is. Okay, I will check this. Okay, now we can proceed. Okay, now, so where I was talking about the IEEE standard, then how it's actually work and the terms like this. Okay, so the term that we call the bridge ID, on the behalf of that, on the basis of that, we elect the switch as a bridge. Okay, so there's nothing about different with the bridge. The switches are also a bridge. Okay, so we have to elect the root bridge, and apart from that, that's all bridge what we call the non-root bridge. Okay, so it means that in a one single root bridge will work in a topology, and that all around the switches will going to be as a non-root bridge. Okay, so we have to elect these all things. So first thing, how the election happen. Okay, so the bridge ID, which is going to be make and going to be change the game and going to be do that's all like election. So in bridge ID, there's two identities that we call the priority number and the MAC address number. So the priority number, as you can see right here, that's all at the top of the 32769, which are the priority number, and below it, as you can see, this is the MAC address. It's quite identical, as you can identify very well. Okay, so we have to find which MAC address. First we have to check the priority number, then if that will going to be tie or some ways it's tie, so we have to then compare with the MAC addresses. Okay, so that we do. So as you can see, this is a priority number, definitely it's going to be tie over here. Then after we have to check it that the MAC addresses to this also in the same way, we have to just a bigger one this, and this all the tying, even the first octet is tying, so I will go in the second octet. So here it is, that this one, like the switch 3 is going to be as it work as a bridge right here in this topology. Okay, so we have to make so what about all around the bridge, what it's actually do. The bridge like root bridge that we call the root bridge, exactly the root bridge, what it's exactly do. So you will see the all ports over the root bridge that will going to be as a forwarding port. Okay, so that will going to be work always is going to be a forwarding port that we call in the same ways like a designated port. Okay, so this on this like F01, F02 and F03, that all the interfaces going to be act like a designated port. Okay, on this topology, and all apart from this switch, apart from this root bridge or root switch, that all switches have a one single root port that we have to find. Okay, so the second thing that we have to understand is the designated port. The F01 is designated port over here on the switch 3. So the next to it, the device which is connected to it, that's the port that should be a root port, because that's near to it. And I will going to be talking about the root cost is also going to be the factor of making this thing. So I will further, like if I will do like this way, like in a big topology where we can make these things in a sense in a better way. But what we have to make is this is the fast Ethernet of port. So for this the cost should be that's cost should be 19. Okay, so let me make understanding about this all interfaces based the cost. So if the interface the speed of the interface is at 10 Mbps, so that should be the cost would be 100. Okay, if the interface is 10 Mbps, that is the Ethernet, so fast Ethernet, so in that's 10 Mbps, if the speed is 10 Mbps, so we have to go with the 19, the cost would be 19. If in case the 1 Gbps speed is 1 Gbps, so in that case the cost would be 4. Okay, and next if the speed is 10 Gbps, so in that case the cost would be 2. So here it is the simple thing. For this the cost will be 19. If this interface, this switch will going to be get this switch, so what the all around the switches try to reach to the root bridge. Each and every interface each and every switch try to connect or try to reach to the switch right here, the which is a root bridge. So the switch 2 will going to also try to reach to the switch 3, which is a root bridge, and switch 1 is also try to do. So there's a 2 option to get this root bridge, to reach to the root bridge. The first is going this way, the switch 1 will go this way to get this switch root switch, and it can go this way to go root switch. So the thing is, what we have to consider right here, the cost would be 19 over here on this interface, which is F02 fast Ethernet. So speed would be 100, so the cost would be 19 on this, that should be 19. So the both cases the cost would be 19 if I will go this way and this way, 19 over here, 19 over here. And about this, so that simple way, that's a simple cost is 19 only. So we have to go always in that with that interface where is the cost is less, and we have to elect the bridge, we have to make the root bridge that switch where is the priority number is less. So we have to consider always the lowest number, whatever the we are electing a bridge, or we are considering or comparing the cost. We have to go always with the lowest in that cases. So the switch 1 is going to be take this way. In the same situation, in the same scenario, the same term is applying over here with the switch 2, so that will going to just choose this way. So I'm just making the sense writer, it will help us to make the things understand better. It will going to make the things right, and things will going to be better to identify. In a sense of identifying, it will going to help us. Okay, so this is going to be the root bridge itself, because of this is near to it, the cost is very less. Okay, so in the same way, this it will also going to be right. If it is, so it's also going to be, yeah. Now we can proceed about this switch. So on the both switches we have done. Okay, so as we know, on a one single switch that should be a one root bridge. So we did it, we done with it. Okay, so the thing is, on this interface what gonna happen? So before doing anything, first we have to make sure what are the things that we have to consider. over here. So first we have to elect the root bridge, then after designated port. Okay, so we have done with the designated port. Then we have to consider what would be the designated port. If this will send this way, okay, then collision gonna happen in this on this switch, on this interface. Okay, so we have to block the interface somewhere. On some case we have to block the interface. So what interface that would be going to be blocked, which interface is going to be blocked in that case? Okay, so we have to consider about this interface. In this interface we have to choose which port is going to be blocked. F01 is going to be blocked or F02 is going to be blocked. Okay, so for this interface, for this port to this interface, we have to compare their both switches. So in this scenario we have to compare this switch and this switch priority number and MAC address. So both are dying at this moment,